Okay, let's just dive right in, shall we? We are going to talk about a feeling that, honestly, millions of us know all too well. That knot in your stomach when you're staring at a page full of numbers and symbols. But here's a wild thought. What if I told you that feeling isn't a sign that you're bad at math? What if it's actually a sign that your brain is working perfectly?
I want you to picture this. You're sitting in a classroom. You can hear that slow tick of the clock on the wall, the squeak and scrape of the chalk. The teacher's hand is just a blur, writing this absolute mess of X's, Y's, and squiggly letters you don't even recognize. And then they draw a box around it. They turn, they smile, and they say, "Just memorize this for the exam." You've written it down, but you have no earthly idea what it actually means.
And that's exactly when the fear starts to creep in, right? That little knot of anxiety. You kind of glance around the room and it feels like everyone else is nodding along. So you start thinking, oh no, I must be the dumbest person in here. Just frantically trying to remember a single step, knowing that if you get one tiny thing wrong, the whole thing just collapses. It's a really lonely feeling. And it's so easy to start telling yourself a story, isn't it? My brain just isn't wired for this. I guess I didn't get the math gene. Have you ever had that thought that maybe some people are just born for this stuff and you're just not one of them? You know, if any of that sounds even remotely familiar, just take a second and hit that like button. Let's just acknowledge that you are absolutely not alone in this. And hey, if you're ready to start building up your thinking skills, this is a pretty good time to subscribe to Brain Power Academy.
But here is the most important point, and this is something that could seriously change how you see this whole thing forever. That anxiety you feel, it's a completely logical and predictable response. It happens when you are taught in a way that literally fights against your brain's natural learning process. Your brain isn't broken. The method is.
In this slide, this shows the fundamental mismatch. I mean, look at it. Your brain is a storytelling, pattern-seeking machine. It craves context. It needs to know why. But school often just throws abstract, context-free data at you and says, here, jam this into your memory. We're not hard drives. We need a story. Trying to force a formula into your head without understanding where it comes from, well, it's like trying to carry water in a sieve. It just spills out as fast as you can pour it in. It's an exhausting, frustrating strategy that is, frankly, doomed from the start.
And that really brings us to the core issue with how math is so often taught. We are consistently given the punchline, that's the final formula, without ever hearing the story, the logical journey that actually makes it meaningful.
Yeah, we're often taught to treat math kind of like history. In history, you just have to memorize that a certain war ended in 1918. It's a brute fact. There's no deep logic to it. But math isn't a collection of facts. It's a language of relationships. A formula isn't some rule that just fell out of the sky. It's the conclusion of a logical argument. And this is where we get to a really critical distinction. The difference between fragile, memorized knowledge and stable, understood knowledge. One creates anxiety, the other builds confidence. It's like walking a tightrope versus walking on solid ground. When you just memorize something, your knowledge is incredibly fragile. I mean, think about the distance formula. If you forget for even a second whether it's a plus or a minus sign in the middle or which x comes first, you have nothing to fall back on. The whole thing is useless. See, memorization really is like walking a tightrope. One little slip and you fall. And that constant fear of falling, that is math anxiety. But understanding, that's like walking on solid ground. If you understand that the distance formula is really just the Pythagorean theorem on a graph, you don't even need to memorize it. You can just rebuild it from scratch anytime you want. All right, enough talk. Let's prove to ourselves right now that your brain is a powerful pattern-seeking machine. We're going to play a quick game. No tests, no memorization, just pure intuition. You ready? Okay, just follow along with me. The first odd number is, of course, 1. Now, the sum of the first two odd numbers, 1 and 3, is 4. Okay? Now, the sum of the first 3, that's 1, 3, and 5, is 9. You got to guess for the next one? The sum of the first 4 odd numbers, 1, 3, 5, and 7, is 16. So, let's just look at that sequence we just made. 1, 4, 9, 16. Does that look familiar? Your pattern recognition brain is probably screaming at you right now. Those are the perfect squares. And you're absolutely right. 1 is 1 squared, 4 is 2 squared, 9 is 3 squared, and so on. So the sum of the first n odd numbers is always n squared.
But, and this is the important part, this is where we go from just noticing a pattern to truly understanding it. Why does this work? Don't just memorize the rule, let's get it. The secret is to stop only thinking in numbers and to start seeing in pictures. We are going to visualize this whole thing with marbles. Imagine a single, cool, smooth marble sitting on a table. That's our first odd number, 1. And it also happens to form a tiny little 1 by 1 square. Simple enough, right? Okay, now let's add the next odd number, which is 3. So take 3 more marbles and watch what happens when we wrap them around that first one. 1 on top, 1 to the right, and 1 in the corner. And just like that, you have a perfect 2 by 2 square. 4 marbles total. Now let's do it again. Let's add the next odd number, 5. Take 5 marbles and wrap them around that 2 by 2 square we just made. You put 2 on top, 2 on the right, and 1 to fill that corner. And what do you see? A perfect 3 by 3 square. This isn't magic, it's geometry. Each odd number is just the next physical layer needed to build a bigger square.
That little click, you know? That feeling when something confusing just becomes obvious. That's what we're after. If you just had one of those aha moments, let me know in the comments. And of course, if you're finding this valuable, a quick like would be amazing.
So, what's the big secret to true mastery? Well, it's not about being a genius. It's about making this fundamental shift from being a memorizer to being a seer, from walking that terrifying tightrope to walking on solid ground. And the absolute best part is, this is not a genetic gift. It is a technique that anyone can learn. Now, I know what some of you might be thinking. Okay, that's a cute trick with the marbles, but what about calculus? What about trigonometry? I can't visualize everything. And you know what? That is a completely fair question. You can't visualize everything with marbles, of course. But the principle of always seeking the why behind the what, that applies to everything. And I know this because I hit a wall with this myself, hard. And the breakthrough for me, it wasn't some moment of triumph. It was a moment of absolute total embarrassment that forced me to change everything about how I learned. And that story, the one that explains how to apply this to even the hardest topics, well, that's what we'll cover in part 2. So if you're ready to continue this journey, make sure you're subscribed.
Welcome back to Brainpower Academy. Now, if you've ever stared at a test question and just felt your mind go completely, totally blank, this explainer is for you. We're about to go way beyond the limits of just memorizing stuff and learn how to build a truly powerful mind. All right, so in part 1, we completely shattered the idea that learning is just about cramming facts into your head. Now, in part 2, we're going to build the solution from the ground up. We're talking about a system for understanding so deep you'll never have to fear that blank page again. And hey, if you're serious about this kind of learning, make sure you subscribe so you don't miss a single step on this journey with us. You know this feeling, right? Every student does. The fluorescent lights are humming, the clock is ticking away, you studied for days, but you look at the question and just nothing. It's like a circuit breaker just flips off in your brain. That feeling of terror is the exact problem we are solving today. But here is the big shift in perspective. What if that blank mind moment isn't actually your fault? What if the strategy you were taught, the whole strategy of memorization, is just fundamentally flawed by design? That's the core idea we're going to dig into. So, let's start by looking at this problem up close, because I guarantee you are going to recognize this story.
Oh man, this was me during my pre-calculus final. I had spent 3 nights fueled by energy drinks, just reciting formulas over and over. I honestly thought I was ready, but then I spent 20 solid minutes on a single question, just staring at it, knowing I had seen the formula 100 times. I finally just guessed, got it wrong, and I walked out of that exam feeling like a total fraud. Like I just wasn't cut out for this stuff.
But you know what? That failure, it led to the single most important breakthrough in my entire academic life. It was the moment I stopped trying to be a memorizer and started learning how to become a builder. This is what my teacher asked me. I went to his office expecting a lecture, but he didn't tell me to study harder. He just asked me this one, simple, powerful question that changed everything. He showed me that the formula I forgot wasn't some random rule. It was just a description of a shape. It was something that could be rebuilt from scratch in seconds.
And this right here perfectly illustrates the difference. A memorizer tries to carry this heavy, clumsy bucket of water. If they stumble, it's all gone. Poof. But a builder knows where the well is. They can go back and get the water anytime they need it. They operate from a place of security, not scarcity.
So, how do we become builders? Well, it all comes down to a really practical 3-step method that you can literally start using tonight to completely transform the way you study. These are our 3 tools: origin, interrogation, translation, and active reconstruction. Let's break down exactly what each one is and, more importantly, how you can use it. Okay, first up, origin interrogation. Every single time you see a new formula, don't just write it down. Stop. Ask, where did this come from? Every formula has a backstory, a logical proof. You don't have to memorize the proof itself, but just watching the story of how it was created one time gives the symbols meaning. The formula for the area of a circle, pi r squared, stops being some abstract thing when you see it actually comes from slicing the circle up like a pizza and rearranging it into a rectangle. It becomes rearranged pizza. It's impossible to forget.
Second is translation. Stop reading math like a robot. You know, v equals 4 over 3 pi r cubed is just a random string of symbols. So translate it into your own language. For instance, the volume of a sphere is a little more than 4 cubes that are made from its radius. Now, what's so fascinating about this is you're engaging your brain's semantic center. That's the part that remembers stories and sentences, and it is way, way more powerful than the part that remembers random symbols.
Speaking of which, I'm genuinely curious. What is the one formula that just haunts you? That one equation that absolutely refuses to stick in your brain no matter what? Drop its name in the comments. Let's see which one is the biggest villain for our community here. And the third, and honestly the most powerful step, is active reconstruction. You have to stop rereading your notes. That's totally passive. Instead, take a blank sheet of paper, write the name of a concept at the top, and try to rebuild it from scratch. Try to derive the formula or just explain it out loud. That struggle, the effort of pulling that information out of your mind, it's just like lifting weights. If there's no effort, you're not building any muscle. If your studying feels easy, you're probably not building strong memories.
Okay, let's put this into practice right now. Let's take on one of the most feared formulas in all of mathematics and see how our builder's mindset can totally tame it. Ah yes, the quadratic formula. It looks like a random mess of letters and symbols, specifically designed to make you panic. A memorizer sees this as a long, fragile string of characters they have to recite perfectly. But a builder sees something else entirely. Just look at these parts. The first bit, negative b over 2a, that's not random at all. That's the axis of symmetry. It's the exact center of the parabola. So that's your starting point. The plus or minus sign? Well, that's just telling you that parabolas are symmetrical. What happens on the right side also happens on the left. And that big, ugly square root? That's just a number that represents a distance. It's how far you have to walk from the center to find the answers. So the whole point is this. The quadratic formula isn't a poem that you have to memorize. It's a set of directions. It simply says, start at the center, then walk a certain distance to the left and to the right. When you see it as center plus or minus distance, the fear just vanishes. You're not recalling symbols, you're visualizing a journey. Now, this whole approach does so much more than just help you pass an exam. It fundamentally changes your identity as a learner. Take a look at this comparison. The memorizer is always operating from a fear of forgetting. Their knowledge is fragile, and it makes them anxious. But the builder? The builder operates from a place of confidence. They're self-reliant and resilient because they know that even if they forget something, they have the tools to rebuild it. So let's recap the transformation. First, you've got to remember that forgetting a formula is a system failure, not a personal one. Second, always look for the story behind the symbols. Third, translate that abstract math into your own human language. And fourth, build deep, lasting memory through the productive struggle of active reconstruction, not the passive comfort of just rereading.
Ultimately, this is what it's all about. We all have calculators on our phones. The point of learning math isn't to compute things faster. It's to learn how to see the hidden structures and patterns that govern the entire world around us. It's about logic, and it's about truth. And that brings us to the final and most important question. What is the one topic, the one concept from your own studies that you are going to apply this 3-step method to first? Don't just watch this, put it into action. If this explainer just flipped a switch in your brain, do me a favor and share it with a classmate who looks as stressed out as you used to feel. And if you're serious about building a more powerful mind, be sure to subscribe. Thanks so much for watching.